Welcome to the 787 Flight Instruments lesson. In this module, we will discuss the PFD, ND, and standby instruments. For ease of use, user selections throughout this lesson will be made directly on the displays. In the aircraft, cursor control devices, or CCDs, are used to select items on the displays. The Inertial Reference System, or IRS, is the primary source for attitude and inertial navigation position information. The major components of the IRS are 2 Inertial Reference Units, or IRUs, and 2 Attitude Heading Reference Units, or AHRUs. The IRU is the primary source for independent inertial navigation position information. The IRU processes information measured by its internal gyros, accelerometers, and GPS inputs. The AHRUs are the primary source for attitude and heading information. The Air Data Reference System, or ADRS, provides primary, secondary, and standby air data. The major components of the ADRS are 6 static ports, 3 pitot probes, 6 air data modules, 2 angle of attack sensors, and 1 total air temperature probe. 3 static ports are located on the left side of the airplane, and 3 static ports are located on the right side of the airplane. The static ports are used to measure static air pressure. 2 pitot probes are mounted on the right forward section of the airplane. 1 pitot probe is mounted on the left forward section of the airplane. The pitot probes are used to measure dynamic air pressure. Left and right static ports are paired through pneumatic tubing to each of the left, center, and right air data modules. An air data module is also connected to each pitot probe. The air data modules convert static air pressure and dynamic air pressure to a digital output for use by other systems. There are 2 angle of attack sensors, one located on each side of the forward fuselage. The sensors measure airplane angle of attack relative to the air mass. A total air temperature probe is mounted outside the airplane to sense air mass temperature. The temperature sensed by the probe is used by the ADRS to compute total air temperature. The ADRS also receives TAT measurements from each of the EEC TAT sensors for a total of 6 inputs. These inputs are used to derive a weighted average or trusted TAT. The Air Data Attitude Source Selector controls the source of airspeed, altitude, and attitude information for the associated PFD and HUD. While the Air Data Attitude Source Selector is in the auto position, the ADRS provides air data to the PFD and HUD. The IRS provides attitude data to the PFD and HUD. And backup airspeed, altitude, and attitude data is automatically provided as required. Normally, the display system will automatically reconfigure to compensate for most faults. If there is an undetected source failure, the non-normal or alternate position provides the capability for manual selection of PFD and HUD sources. Moving the source selector to the alternate position results in backup airspeed and altitude are displayed on the on-side PFD and HUD, and ISFD attitude is displayed on the on-side PFD and HUD. The PFDs present a dynamic color display of all the parameters necessary for flight path control. The PFDs provide the following information: flight mode enunciation, airspeed, altitude, vertical speed, attitude, steering information, radio altitude, instrument landing system display, approach minimums, heading track indications, and engine fail, GPWS, and PWS alerts. The mini-maps present a tactical display map with a fixed range of 20 nautical miles. They are displayed on the outboard DUs immediately below the PFDs. The mini-map provides the opportunity to display the flight path, flight plan waypoints with ID and constraints, altitude profile points, alternate airports, runway information, TCAS targets, terrain depiction and alert patterns, weather radar return patterns, and heading track indications. The mini-maps do not display information such as untuned nav aids, background waypoints, and background airports. When a system failure occurs, a failure flag will be displayed in place of the failed system. Displayed information is removed or replaced by dashes if no valid information is available to the display system. The displays are removed when a source fails or when no system source information is available. Airspeed is displayed on an airspeed tape and digital window on the left side of the PFD. The airspeed indications consist of the selected speed, the speed trend vector, current airspeed, current Mach, maximum speed, maximum maneuvering speed, the selected speed bug, takeoff reference speeds, the VNAV speed band, flap maneuvering speeds, landing reference speeds, minimum maneuvering speed, minimum speed, and landing flap and VREF speed. Review the airspeed information and press Continue to resume the lesson. Altitude is displayed on an altitude tape and digital window along the right side of the PFD. The altitude indications consist of the selected altitude bug, the altitude trend vector, selected altitude, current altitude, the landing altitude reference bar, the baro minimums pointer, landing altitude indication, minimums reference, minimums, the barometric setting, the barometric reference, the QFE altitude reference, the autopilot flight director barometric source, the pre-selected barometric setting, QFE, and the uplinked barometric setting. Review the altitude information and press Continue to resume the lesson. Vertical speed is displayed to the right of the altitude indications with a scale and pointer. The vertical speed indications consist of the vertical speed pointer, the selected vertical speed bug, and vertical speed. Review the vertical speed information and press Continue to resume the lesson. The attitude indication is located in the center of the PFD. The attitude indication displays the airplane pitch and roll attitude referenced to the horizon. The attitude indications consist of the bank pointer, the slip skid indication, the pitch limit indication, the horizon line and pitch scale, the bank scale, the airplane symbol, flight director pitch and roll bars, the flight path vector, or FPV, and the selected flight path angle, or FPA. The flight path vector, or FPV symbol, represents airplane flight path angle vertically and drift angle laterally. The flight path vector is displayed on the PFD when the EFIS control panel FPV switch is selected on, or the MCP FPA reference switch is selected on. The FPV shows the flight path vector above or below the horizon line and a drift vector left or right of the pitch scale's center. The flight path angle symbol shows the selected flight path angle when the MCP FPA reference switch is selected on with either the autopilot engaged or flight director on. The FPV and FPA symbols are displayed in two sizes and brightness levels. The large, bright FPV FPA symbols are displayed when the previously stated selections are made and the flight director is off. The small, dim FPV FPA symbols are displayed when the previously stated selections are made and the flight director is displayed. Review the attitude information and press Continue to resume the lesson. The radio altimeter measures airplane altitude above terrain. The current radio altitude is displayed in the bottom center of the attitude indication area when radio altitude is below 2,500 feet AGL. There are two radio altitude systems, left and right. If both radio altitude systems are inoperative or degraded, the radio altimeter left and right advisory message is displayed on the ICAS, and RA is displayed on the PFD. The radio altitude systems send data to the autopilot, the autothrottle, GPWS, TCAS, weather radar, and the primary flight control systems. Actual navigation performance, or ANP, and required navigation performance, or RNP, indications are displayed when LNAV is armed or active, VNAV is active, or TOGA roll mode is active. The navigation performance scales and pointers present a real-time display of the location of the LNAV and VNAV path relative to the airplane. The airplane position is represented by the center index on the scale and the LNAV or VNAV path by a magenta pointer. The deviation scales are proportional to RNP. The deviation represented by the distance from the center index to the outer index is equal to the RNP value in the FMC. For example, if RNP is equal to 1 nautical mile, then the distance between the center index and the outer index represents 1 nautical mile. The ANP bars are anchored to the outer index and vary in length depending on the precision of the navigation system. When GPS updating is available, the ANP value is small and the bars are short. When GPS updating is not available, position uncertainty increases and the ANP bars grow toward the center of the scale. The gap between the ANP bars represents the area where the magenta pointer can be and still have the airplane remain within the RNP for that part of the route. If the deviation pointer moves into an ANP bar for 5 continuous seconds, the ANP bars and scale turn amber, and the pointer flashes for 10 seconds. When ANP equals or exceeds RNP, the ANP bars touch at the center of the scale, the ANP bars turn amber, the deviation pointer flashes for 10 seconds, and the nav unable RNP message is displayed on ICAS. Review the navigation performance information and press Continue to resume the lesson. Instrument Landing System or ILS indications include ILS glide slope and localizer deviation, frequency identification, DME, course, and marker beacon indications. The approach reference and navigation source information appears above and to the left of the attitude display. This information displays selected ILS identifier or frequency approach front course, ILS DME distance, and navigation source annunciation. The marker beacon indications are displayed in the upper right corner of the attitude display area. The marker beacons include the outer marker, the middle marker, and the inner marker. The glide slope pointer and scale appear on the right side of the attitude indication. The localizer pointer and scale appear at the bottom of the attitude indication. When the autopilot or flight director is in loc mode and the airplane is close to the runway centerline, the localizer scale changes to an expanded localizer scale. In the expanded localizer scale, a rectangle equals 1/2 dot deviation, making the expanded scale twice as sensitive. Review the ILS information and press Continue to resume the lesson. Integrated Approach Navigation, or IAN, indications include FMC glide path and FAC deviation, approach identifier, distance, and course. The approach reference and navigation source information appears above and to the left of the attitude display. This information displays the type of approach, runway, and approach front course, the missed approach waypoint name and distance to that waypoint, and source annunciation. IAN glide path and FAC deviation indications are displayed in the same way as ILS. Deviation indications will appear when a valid IAN procedure is selected. Review the IAN information and press Continue to resume the lesson. Selected heading track information is displayed in the bottom section of the PFD on the mini-map. The mini-map is a track-up display, meaning the 12 o'clock position of the display will always depict the current track of the aircraft. When flying in strong crosswind conditions, the aircraft heading, as indicated by the white triangle, will display to the right or left of the track line. The MCP selected heading bug is displayed on the outside of the compass rose. The MCP selected track bug is displayed on the inside of the compass rose. Heading or track is selected by pushing the heading track reference switch located on the MCP. The selected heading or selected track is enunciated below and to the left of the airplane symbol. The current heading or track reference is shown below and to the right of the airplane symbol. The aux area outboard of each PFD consists of two distinct areas: a clock and flight information area and an ATC data link block. The clock and flight information is located in the upper part of the aux display. The clock and flight information section includes the flight number, the MIC readout, the transponder code, cell call, the airplane tail number, UTC time, the date, the elapsed flight time, and the chronograph dial and readout. The ATC data link block is located in the larger lower part of the aux display. The data link block displays uplinked messages, communication system generated messages, and ATC and flight information uplinks. A clock is located on each aux display. Each clock displays UTC time and date, which are automatically generated from the GPS. In addition to time, the clocks also provide elapsed time and chronograph functions. On power up, the timer is set to 0. Elapsed flight time starts automatically at weight off wheels and ends at weight on wheels plus 30 seconds. When on the ground and V-speeds are entered into the CDU, the timer resets to 0. The chronograph consists of an analog dial and sweep second hand. The pilots have independent control of the chronograph displays. The chronograph is controlled using the clock switch on the glare shield panel. Subsequent pushes of the clock switch will start, stop, and remove the chronograph from display. The NDs provide a mode-selectable color flight progress display. The two available ND modes are Map and Plan. They can be selected by selecting ND on a display select panel or multifunction keypad, then selecting Map or Plan at the top of the ND with a cursor control device. The map mode can be switched between an expanded mode with a partial compass rose and a centered mode with a full compass rose. Both map and plan modes can be shown in normal and full display format. A normal display ND is shown on 1/2 of a DU. A full display ND is shown on an entire DU. The following symbols can be displayed on each ND, depending on EFIS control panel switch selections. Review the ND symbology before selecting the Continue button to resume the lesson. The plan mode is recommended for use during pre-flight to verify the active route. The plan mode is always presented true north up. The active route may be viewed using the step prompt on the CDU legs pages. Displayed information can include ground speed, true airspeed, wind direction and speed, map range scale, active waypoint information, and selected navigation data points. Additional information selections can be displayed via the menu at the top of the ND. These selections include airports, waypoints, additional navigation facilities, and route progress. The plan mode also has map centering keys located at the bottom of the ND. Selecting one of these keys will center the map on the corresponding item. The keys include Airplane, which centers the map on the current latitude and longitude of the airplane, Destination, which centers the map on the destination airport, Cursor, which recenters the map on the position where the cursor clicks, and Center On, which centers on any database item or latitude-longitude coordinate already entered in the scratchpad. The map mode is recommended for most phases of flight. Presented track up, this mode shows airplane position relative to the route of flight against a moving map background. Displayed information can include selected and current track, selected and current heading, position trend vector, range to selected altitude, map range scale, ground speed, true airspeed, wind direction and speed, next waypoint distance, waypoint estimated time of arrival, and selected navigation data points. While in map mode, weather radar and terrain information can be displayed. These selections can be made from the menu at the top of the ND. Weather and terrain are not selectable at the same time. Additional information selections can be displayed via the menu at the top of the ND. These selections include traffic, airports, waypoints, additional navigation facilities, position information, and route progress. The ND compass rows can be referenced to magnetic north or true north while in map mode. The heading reference switch is used to manually select magnetic or true reference. The compass display will automatically reference true north when the airplane enters the polar regions with the heading reference switch in norm. The vertical situation display, or VSD, presents a profile view of the airplane and its environment. To display the VSD, select VSD from the Map Information selections on the Map Mode drop-down menu. The VSD will be displayed on the bottom third of the ND. The VSD depicts terrain and waypoint information that is within the en route corridor on the ND. The VSD range is a function of the ND range and is depicted on the horizontal reference scale. The normal display VSD has the same range as the ND, except when the ND range is less than 5 nautical miles. The full display VSD has twice the range of the ND, from 10 to 2,560 nautical miles. The altitude reference scale is linked to the VSD range and is not independently adjustable. This ensures that a consistent 3-degree glide path is depicted up to an 80 nautical mile range. The selected altitude shown on the VSD is the same as the selected altitude shown on the on-side PFD. An airport map can be integrated with the ND in both map and plan mode. The map consists of runways, taxiways, aprons, and buildings with the appropriate labels. The airport map is automatically displayed when the airport is either the origin or destination airport in the active flight plan, the airport is in the airport map database, and the ND range is 5 nautical miles or less. Failure flags are displayed for system failures or invalid information. Indications are removed or replaced by dashes when source system information is not available. The message "Excess data" is displayed if the amount of information sent to the ND exceeds the display capability. When this occurs, the primary display system removes information from the center of the display outward. Information near the outer selected range area is still displayed. The message can be removed by reducing the amount of map information, reducing the range, or deselecting one or more of the map information selections. This section allows you to experiment with selectable navigation display information. When you have completed the navigation display practice, press the Continue button to complete the lesson. An Integrated Standby Flight Display, or ISFD, is located on the center forward panel. The ISFD displays attitude, airspeed, altitude, ILS, and heading. The ISFD receives airspeed and altitude from the center pitot and static air data modules. Attitude information is provided by internal inertial sensors. ILS information is provided by the left INR receiver. The display receives its heading information from the same source as the captain's primary flight display. Detection of a momentary out-of-limit ISFD condition may cause the attitude display to blank, and the wait attitude or attitude reset message to display. When the attitude reset message displays, pushing the attitude reset switch resets the horizon line with the airplane symbol. On the ground, the attitude reset switch should only be pressed when the airplane is stationary. In flight, the attitude reset switch should only be pressed while the airplane is in wings level, non-accelerated flight. During attitude reset, the attitude 10-second message displays. Failure to maintain straight and level for 10 seconds may result in another attitude reset message. A standard liquid-damped magnetic standby compass is located below the overhead panel. A compass correction card is also located near the compass to provide heading correction factors.